Yeah, so let's talk about memory management, right? So when you are designing a language, memory management is like a very crucial decision to make. So how will you manage memory for your language, or like whatever application you're writing in, right? So will you delegate it to the user? Let's say that a lot of low-level language does. If you have worked with C, C++, they have sort of like syntax to allocate and syntax to free memory from whatever variable you're initializing, while other languages do it internally, right? So internally they have some mechanism to handle clearing and having memory and whatnot, right? So we have sort of a similar thing with JavaScript. So JavaScript has something called garbage collector. So what garbage collector does is it's responsible for periodically checking in and clearing memory for whatever unused or old resources that are being sort of consuming memory and that are not used in the application, right? So you don't have to worry about it. It does it internally, which sort of is convenient when you're writing code, because it's like a less thing to worry about. So you can just focusing on writing your business logic, and all the memory management and deallocation and whatnot would be handled by the language itself. But that also brings in a lot of drawbacks as such, because that's not something that comes to our mind in general when you're writing JavaScript about how it allocates or deallocates. So we don't consider that. So when we don't consider that, that leads to sort of us initializing listeners, and we sort of forget them to nullify the reference or whatever, right? So we have something initialized, we use it once and then forget about it. It's not like it can be something that your code perceives as it will be used, but you really know that you won't use it. But since that decision is not yours to make and you are not worried about that, it sort of leads to a memory leak. So that's what. Now let's say now we have a small demo here. So here what the demo does is when I click on create DOM elements, it will create 10,000 elements in the screen, as you can see. If I click on remove, it will remove all of them. And what happens is when I create the DOM elements, there is a array in the parent which is sort of getting initialized with how many elements we want, and based on that we add these elements. And when I remove, it sort of clears the array and it re-renders the UI based on that array, right? And when we nullify the reference, we sort of clear out the whole reference from that array, so we cannot access that array anymore after that. Now let's see what happens. Let's run our test. So what we would do is we would basically, there is this console tab, just move on to the performance tab that you have here. If you notice, there is a small dustbin icon here which says collect garbage, if you can read that. So it sort of does what it says. It collects garbage, it clears out the unused memory, right? So if you want to run some tests and if you want to manually trigger it, you can do it from here itself. So now let's run our test and let's start recording. So we will run a very simple test. Let's clear the garbage, whatever is collected, just to get a clear initial state. And from 10 seconds, we create DOM element, we create twice, we create thrice, we create another time, we remove the DOM elements, we trigger garbage collection, because you cannot predict when it will be triggered. So since we are running test, we are manually triggering it here. And then we again create elements, and then we nullify the reference, and then we again trigger garbage collection. So let's wait for 5 seconds. Let's wait till 40. Stop. Now you can see the curve, right? So what happens is we did 5 events of allocation, then we remove the elements, then we did 2 events of allocation, then we nullified the reference to that array. But what goes on here? We have 1, 2, 3, 4, 5 sort of spikes. As you can see, 1, 2, 3, 4, and yeah. So no, we have 4 events, not 5 events. So we have 4 allocation events. You can see the initial spikes, and then we have all elements removed, but nothing changed here. It's the same. So it didn't change anything. But the expectation was, let's say if we remove elements, it should not be here. But since we have a parent array which is holding a reference and we are sort of just re-rendering it based on the event, it's not doing much. So the parent array still has the elements, we are just not showing it in the UI. So this is a memory leak, as you can see. Here is I'll just show you the code. So here is the array that you have, DOM elements. When you click something, it just sort of appending or removing the child, but this parent element still has a reference, or it still exists. So this is an example of memory leak, as you can see, because when we were in this state, there wasn't anything visible in the UI, but like, what to say, it still consumed the same amount of memory as this, which is not ideal. Then we sort of again initialized, I think 2 times. So we can see 2 spikes, and then we set it to null. We set the initial array as null, and then we triggered garbage collection. So the rendered part was already there since we didn't trigger another re-render, but after setting it to null, if we would have triggered a re-render, the screen would have been cleared. But after doing this, we didn't re-render the UI, so it's showing sort of the last state that we have. Now if we create DOM element, nothing will happen because we sort of nullified the reference to it, so we cannot do that anymore, or we cannot add elements and re-render that again. As you can see in the code, we have created elements, then we are doing sort of DOM elements dot push, but this won't be there. Right? So what we have is so what we have is, we can see there is a very huge dip here. So why did that happen? And this happened right after we sort of set the reference to DOM elements as null, right? So we sort of reference it to null, and then this happened when we triggered the garbage collection. So if you zoom in, if you just follow this line towards the top and you check the events that are being going on for this period, you can see it says a major GC. So we sort of clicked the garbage collection manually for it to happen, because we did not want to wait for JavaScript to sort of detect it on its own, if I can speak properly, which it would have done eventually, but that's not very predictable. Sometimes it does it instantly, sometimes it doesn't. So for testing, we cleared it on our own, and then what happens is I think I clicked it 3 times. So these are 3 events that are triggered for garbage collection, but the memory got cleared, unused memory got cleared in the first click itself, and it went down, right? So that's the point that I'm trying to make here. So that's how garbage collection works mostly. And from your code, you won't be able to do this, like click something or like pass an event for it to collect the garbage. So let's say you had this, you removed all the elements, but you forgot to nullify the parent reference of anything, right? Or something that is still holding the data, be it an event listener, be it some array with data, the memory won't be cleared. So you have to sort of, even if it does it for you, you have to sort of be conscious about the things that you use, and like when you sort of don't use them anymore, right? So it makes a lot of difference. Yeah, so I think that should be it for this video. Like, do share it with your friends if you liked it, and if you have any suggestions, feel free to reach me out or comment it down. So yeah, see you folks, bye.